2.5, Day 2, graphing rational functions. The function we're looking at today, or for this third clip of graphing, is this one, letter C. I'm going to quickly put this in my calculator and then I'm going to go about my work. So I have in the numerator in parentheses x squared minus 7x plus 10, whoops, close parentheses, divided by in parentheses x minus 3, although it's probably going to be changing if it's factorable. This is x. Factors of 10 will never add to, yeah they will, x minus 5 by x minus 2. They'll multiply to negative 10 and add to negative 7. In the denominator, x minus 3. None of them cancel, so I have no holes. There is one factor in the denominator that will lead me to a vertical asymptote at x equals 3 when I set it equal to 0 and solve. There will be two x-intercepts when I look at these factors that are in my numerator of the simplified function and set them equal to 0. My x-intercepts will be at 5, 0 and at 2, 0. My y-intercept, to get my y-intercept, I will plug 0 into the function. So I'm going to do that right now in my table. Plugging in 0 gives me negative 3.3. Let me see, that'd be negative 5 times negative 2, which is positive 10 over negative 3, be negative 10 thirds. Let me just double check this. Negative 10 thirds is negative 3.3, so we know we got it right. Last but not least, for part 1, stating the horizontal asymptote. Well, the degree of the numerator is bigger than the degree of the denominator, so there is no horizontal asymptote. However, there is a slant asymptote. The slant asymptote is found by dividing the numerator by the denominator. I'm going to use synthetic division for that. So this would be, if it's x minus 3, then I'm going to put 3 in the box, positive 3 in the box. And so this becomes 1, 3, negative 4, negative 12, negative 2. This is my remainder constant x. So my slant asymptote, I want everything but the remainder. I want the quotient without the remainder, will be y equals x minus 4. And we'll see that on the graph in just a minute. There's my answers for part 1. We have all the asymptotes, no horizontal, but we have a slant. This is new for many of you in pre-calc. Now I'm going to look at graphing this. I have x equals 3 as my vertical asymptote. So I'm going to put a nice orange thicker dashed line so you can clearly see that horizontal asymptote. At x equals 5 and x equals 2, those are my zeros, so I'm going to plot those. X equals 5 and x equals 2. I have no holes. I have no horizontal asymptotes. We do have a slant asymptote at y equals x minus 4. I'm going to use slope-intercept form to graph that. That would be a slope of 1 starting at negative 4, going up 1 over 1. I'm just going to quickly do some dots here to make myself a nice little dashed line for that slant asymptote. Put a dash mark through each one of those dots. There's our slant asymptote. Now I need some values because that's all I have. I have a y-intercept of 0, negative 10 thirds, which is negative 3.3. So my x or my y-intercept is here. What that tells me is that on my left side, it's coming down as I go to the left, approaching this, and as it goes up, it's going to approach this vertical asymptote. Over here, I have a feeling it's bound by those two, but we're going to look at it on the graph to find out, and we're going to plug some numbers into the table like 7, which is 2.5. 7 is 2.5, and we're going to plug in 10, which is 5.7. Notice that's right up there against just before the ordered pair for that. And I'll put in like 4, which is negative 2. So what's happening is, as it comes down from this 0, it gets closer and closer to this vertical asymptote, but as it goes up and to the right, it's approaching that slant asymptote. I can actually look on the graph and see this. There's my graph. I can't put in my vertical equations, but I can put in my slant height just to see x minus 4 and hit graph, and I can see my slant asymptote right on that graph as well. There's part 1. For part 2, actually part 1 was this right here, including our slant asymptote. That's all part 1. Part 2 was to graph and state the domain. The domain means it's going left forever, it's going right forever. The only interruption in x values is x equals 3. So my domain is interrupted by x not being able to equal 3. My domain is negative infinity up to 3 and 3 to infinity. For my end, that's part 2. For part 3, my end behavior. Well, as I go to the right, it's going up infinitely as it follows that positive line with the positive slope. And as I go left more and more, it's going down infinitely. So the end behavior is not limited by a slant asymptote, only limited by horizontal asymptotes. So in this case, the limit on f of x as we go to the left is negative infinity. There is no limit. It's going to shoot down infinitely. And the limit on the output, f of x, as we go to the right, well, there's no horizontal asymptote, so there is no limit. It is shooting up infinitely. The outputs are getting higher and higher and higher in a positive direction. This concludes the notes for 2.5, graphing rational functions.